Have you ever looked at a flight map and wondered why your plane to Asia takes such a peculiar route? It seems counterintuitive that a flight from Los Angeles to Tokyo would venture north over Alaska instead of taking the seemingly shorter, direct path across the Pacific Ocean. Today, we're going to unravel this fascinating aspect of modern aviation and discover why airlines prefer the scenic route. The answer lies in a combination of geography, physics, and economics that most passengers never consider. Let's start with the most fundamental misconception: our understanding of maps. We've all grown up looking at flat, rectangular world maps that distort our perception of distance and scale. These maps, typically using the Mercator projection, make the Earth appear as a flat surface when in reality, we live on a spherical planet. This spherical nature of Earth creates something called the Great Circle Route, the shortest distance between 2 points on a sphere. While it might look like a curved line on a flat map, it's actually the most direct path when you consider Earth's three-dimensional shape. Think about it like this. If you were to stretch a string between 2 points on a globe, the path it takes would represent the Great Circle Route. When airlines plan their routes, they're not just looking at a flat map and drawing straight lines. They're using sophisticated software that accounts for Earth's curvature to find the most efficient path. This is why a flight from North America to Asia often appears to take a northerly route over Alaska and the Arctic regions. It's not a detour, it's actually a shortcut. But the story doesn't end with geometry. Earth's atmosphere plays a crucial role in flight planning through the jet stream, a fast-moving river of air found at cruising altitudes. The polar jet stream, which typically flows west to east at speeds up to 250 miles per hour, can significantly impact flight times and fuel consumption. Airlines strategically plan their routes to either take advantage of these tailwinds or avoid strong headwinds. Flying eastbound with the jet stream can reduce flight time by up to 2 hours and save thousands of gallons of fuel. Conversely, westbound flights often take longer and require more fuel to fight against these powerful winds. This is why your flight time from Tokyo to Los Angeles might be notably longer than the outbound journey. The economics of these route choices are staggering. For a typical long-haul aircraft, fuel costs can represent up to 30% of operating expenses. By optimizing routes to use great circle paths and favorable winds, airlines can save millions of dollars annually. A single flight might save several $1,000s in fuel costs by taking advantage of these natural phenomena. Safety considerations also influence route planning. While modern aircraft are incredibly reliable and certified for extended operations over water (ETOPS), airlines prefer routes that keep planes within reasonable distance of potential emergency landing sites. The transpolar route over Alaska provides access to numerous airports in Canada, Alaska, and Russia, offering more options in case of an emergency than the vast Pacific Ocean. Weather patterns play another crucial role in route selection. The Pacific Ocean can experience severe weather systems, including typhoons and powerful storm cells. The polar route often provides more stable weather conditions and allows for easier diversions around adverse weather when necessary. But there's more to consider than just weather and winds. Political considerations and airspace restrictions can also affect route planning. Some countries restrict access to their airspace or charge high fees for overflight rights. Airlines must navigate these diplomatic waters while planning their routes, sometimes leading to paths that might seem unusual to passengers. The technology behind these route decisions is fascinating. Modern flight planning systems consider hundreds of variables, including weather forecasts, wind patterns, aircraft performance characteristics, and even the cost of fuel at different airports. These systems run countless simulations to find the optimal route for each flight, balancing safety, efficiency, and cost. The impact of these routing decisions extends beyond just time and fuel savings. By optimizing flight paths, airlines can reduce their carbon footprint significantly. A more efficient route means less fuel burned, which translates to lower CO2 emissions. In an era where environmental concerns are paramount, this aspect of flight planning has become increasingly important. Looking to the future, these routes might evolve further. Climate change is affecting global wind patterns, potentially altering the jet stream's behavior. Additionally, new aircraft technologies and improved weather prediction capabilities might open up more efficient routing options. Some airlines are already experimenting with artificial intelligence to optimize their route planning further. The development of supersonic and hypersonic passenger aircraft could also change these calculations. At extremely high speeds, the benefits of great circle routes become even more pronounced, and the impact of wind patterns changes significantly. As these technologies mature, we might see yet another evolution in how airlines plan their routes. It's worth noting that these routing decisions aren't static. Airlines constantly adjust their flight paths based on daily and even hourly changes in conditions. A route that was optimal yesterday might not be the best choice today due to changing winds, weather, or other factors. This dynamic nature of flight planning requires sophisticated real-time monitoring and adjustment capabilities. So the next time you're on a flight to Asia and find yourself crossing Alaska, remember that you're not taking the scenic route. You're actually on the most efficient path possible. It's a testament to human ingenuity that we've learned to work with Earth's geometry and atmospheric patterns to optimize our air travel, making it safer, more efficient, and more environmentally friendly. The complexity of flight routing reminds us that sometimes the shortest distance between 2 points isn't a straight line, at least not on our spherical planet. It's a perfect example of how understanding and working with nature rather than against it can lead to better solutions in modern aviation.